post it to my YouTube channel and and I'll post that to Schoology. Feel free to subscribe to my YouTube channel if you like. Turn notifications on so you can see when I drop a new video. Although I do also drop the pre-calculus videos, you can ignore those ones. Or you can just like and comment on them.
You should apply for monetization. You might as well make money if you're gonna upload it.
Yeah.
Might as well, you know.
Right. I used to monetize. I think I think I got like $50 over after like 2 years.
Yeah, so much.
No, I don't vlog. No, I just do math videos. Couple of issues with the monetization though. Like, yeah, I got like $50 after like 2 years because the way the YouTube like payments work, the monetization, like if you have one video with like 10,000 views, that's like way better than 1,000 videos with 10 views.
Okay.
It's like, yeah, you get like almost nothing, and that's more what I have because like I just make a ton of videos and then a few people, just my students watch them. So I don't know. And then there's other issues like because sometimes like these notes I use the software for, like I think you can see, does it show it here? Oh no, it doesn't show it here, but this is actually copyrighted, so I could get in trouble if I monetize this. If you don't monetize it, they don't care. But if you monetize it, you could get in trouble. So it's just.
I doubt they're gonna come after you for $50.
No, it's true, but it might not. I mean, they might not sue me for money, but it could be like a criminal thing. Like I don't want to go to jail, you know.
Or you get like a strike on your.
Right, or like a fine, yeah. So I don't know. It's not enough money to make it worth the hassle. Yeah. Okay. Cool. Let's all right. Thank you, Luke. Let's go ahead and get started here then. So we're going to do these problems here. So it says solve each equation, round your answer to the nearest 10,000th. So 10,000th, how many decimals would that be? I'm not even sure off the top of my head. So let's draw it out here. So this would be the 10 after the first decimal after, or sorry, the first number after the decimal is the 10th. Let's clear that. I want to do like nearest 10,000. So the first decimal after the first number after the decimal is the 10th, and then the 100th, and then the 1,000th, and then the 10,000th. Okay, so they want us to go to 4 decimals here. So that's going to be the 4th decimal place on all of these, and all of these should really be decimals. Okay, so let's get started then on number 1. We're solving an exponential equation. We actually kind of did some of these earlier, if you remember. We did exponential equations, and they would look something like, let me like draw an example here. You don't have to write this one down, just kind of pay attention. So we would say like 3 to the power of like, I don't know, 2x equals 9, right? And then we would be like, oh, okay, well, 9 is really just 3 squared. So I could say 3 to the 2x equals 3 squared. And then you got the bases to be the same. And we would say 2x equals 2. And then just solve it like that. And x equals 1, right? You guys remember we used to do those? Yeah, that was fun stuff, right? Okay. Well, so it's kind of like, these are kind of like that, okay? We see we have a variable in the exponent, right? And if you didn't get that written down, don't worry about it. Let's just, let's do these ones we're actually doing today. So we have a variable in the exponent again. It's an equation. And so the first thing I need to do is isolate the base of the exponent here. So this one, it has this plus 6 here. I want to subtract that 6 over to the other side. So 3 to the power of a minus 7 equals 71. Okay. So now if we were doing it like those ones we were doing earlier, I'd have to think of like, all right, 3 to what power gives me 71, okay? And the problem here is like, if I did 3 to the 3rd power, that's 27, and 3 to the 4th power is 81. So it's not 3 to the 3rd power, it's not 3 to the 4th power, it's somewhere in between those two, but I don't know exactly what it is, right? And so I'm not able to do this using the way that we did it earlier. Okay, so how are we going to do this? Well, there's a kind of a hint up here. It says exponential equations using logs. So now that we have this as an exponential equation with the base isolated, we can switch it into logarithmic form. All right, so I'm going to go ahead and switch it into logarithmic form. So we did this before already. So we go log, and then remember I always said the base of the log was the base of the exponent. So in this one, the base of the exponent is 3. So that's going to become the base of my log. So log base 3. Then I always said it wants a new partner. So right now, 3 is with a minus 7. It doesn't want to be with a minus 7 anymore. So it's going to get with 71, which means a minus 7 is over here all by itself. So now I've moved a minus 7. I've moved what was in the exponent is now like on its own side of the equal sign. And so now it's in a place where it's easy to solve, okay? Okay, so next step. My next step is going to be, what do I want to do? I actually want to add this 7 over. So I'm going to say this is log base 3 of 71. I'm going to put some parentheses around that, plus 7. The parentheses around 71 are actually not super important, but I'm just trying to emphasize to you guys that the plus 7 is like not part of the log. It's like out back, okay? It's separate from the log. And then my last step here is I want to get this into a spot where I can type it into the calculator. So like that quiz question we were just looking at, if I want to type this into a calculator, I can't type it in as a log base 3. So what I have to do then is just say log 71 over log 3. And then I'm just going to keep that plus 7 out back. And that's equal to A. So this is what I'm going to be able to type into a calculator to get my answer here. So let me do that now. Log 71 over log 3 plus 7. So I want to make sure the plus 7 is kind of not part of that fraction. You don't want to go down here and say like plus 7 like that. Don't do that. Okay. All right, so I got 10.880058434646. All right, we got a long decimal there. So we're trying to go to the 4th decimal place. So I'm going to round it to that 0 right there. But if I'm rounding it to the 4th decimal place, I actually have to look at the decimal right after that. So you can see that the decimal right after that is a 5. So that means this 0 is going to round up to a 1, correct? So you look at the one you're trying to round to. And if the number after that is 5 or more, you round it up. If it's 4 or less, you round it down, okay? So I'm going to put 10.8801. There we go. All right. Cool. So does that mean I could have solved that other problem, the example I did before that we used to do? Could I have used logs for that one? The answer is yes. Here, let me do that one really quick here. So I think the example I gave was like 3 to the 2x equals 9. So if I made that log base 3 of 9 equals 2x, and so then I said log 9 over log 3 equals 2x. And then I divided that by 2. So I put the 2 down there. So I did log 9 over 2 log 3. Let's see what that would have given us. So it gave us 1, which is what we got when we did it the other way, okay? All right. Let's try another one here. Number 2 is a little bit different. So pay attention now. All right, so number 2, it says 5 times 11 to the power of r plus 5 equals 31. So I told you the first thing we want to do on all of these is isolate the base. So the base here is 11. So 11 is my base. So I want to isolate 11, okay? So what 11 to the power of r plus 5. So what is making 11 not able to be isolated? It's this 5 out front here, okay? So what can I do with that 5 out front? Well, I cannot multiply it by the 11. I can't do 5 times 11 and just call it 55 to the power of r plus 5. I can't multiply because I have to do PEMDAS, right? Order of operations says I have to do the exponent first, and I don't know what the exponent is. So instead of that, what I do if I have a number multiplying in front of my base, I divide it over to the other side. So that cancels it out. So then I have 11 to the power of r plus 5 equals 31 over 5, okay? I got a fraction over there. I could type that fraction into a calculator and get a decimal if I wanted to. I kind of don't want to though, because I'm going to type it into a calculator in a minute anyway inside of a log. So I'm just going to hold up on that. I'm just going to leave it as a fraction. All right. I'm sorry. Trigger warning here. We have a fraction. Okay. If some of you are scared of fractions, don't worry. We're not going to have to like do anything with this fraction. We're not going to have to like add it with a common denominator or whatever. We're just going to put it inside of a log. Okay. All right, so now we're ready to switch it into log form. So I'm going to go log base, and the base of my exponent is 11, so the base of my log is going to be 11. It wants a new partner, so 31 over 5 is going to go inside of the log, and then that's going to equal r plus 5. All right, next up, I'm going to subtract the 5 over to this side. So we'll go log base 11 of 31 over 5 minus 5 equals r. And then lastly, we got to use our change of base formula to get it calculator ready. So my change of base formula is going to look like this. I'm going to do log of 31 over 5 over log 11. So remember, the base goes on bottom, right? Keep that minus 5 kind of separate, and then equal it to r. So kind of look back to what we did on the previous question. It was log base 3 of 71. So we had log 71 over log 3. Same idea here, log base 11 of 31 over 5. So that's log 31 over 5 over log 11, okay? So what's like inside the log goes on top, and then what was the base now goes on bottom. It's no longer the base because now these are both base 10. Okay, so now we're ready to get this into the calculator. Just get our decimal answer all in one shot here. Log 31 over 5 over log 11. What I really like about, oh, I just ruined it. Never mind. What I really like about Decimos is if I would have saved that previous calculation, I could have just gone in and edited it. So I'm going to do that this time. I'm going to leave it in there. So log 31 over 5 divided by log, what was our base here? Oh, yes, 11. And then minus 5. So we get negative 4.2391. I look at the 1 right there, the fourth digit after the decimal, and look at the number after that. It's a 0, so it's going to go down. So negative, or it's going to stay down. Okay, so negative 4.2391. All right, are you guys ready to try a couple? All right, I want to give you guys, I don't know, I'll give you 3 minutes here to do number 3. 3 minutes for number 3, that sounds good. All right, I'm gonna start my timer right now, and then we shall go over it. So trying out number 3. Number 3 gonna go very similar to number 1, I would say. If you don't have your own calculator, you can use decimals just like I did. You're on a computer right now. All right, we got a minute and a half left, so I will show you the first step here if you haven't gotten it yet. Would be to add 9.7 over to the other side. All right, you got about 30 seconds left. I'll show you the next step. Would be log base 6 of 21.7 equals b plus 10. Change it into log form. The base is the base and it gets a new partner. So the log base 6 and then 21.7 equals b plus 10. All right, 10 seconds left. Go ahead and subtract the 10 over. And 3 minutes is up. So if you've gotten the answer, good job. Let's see if you got it right. So last step here is to get a calculator ready, which I would do as log 21.7 over log 6 and then minus 10 equals b. All right. So I'll just go here, replace this one with a 21.7, replace this one with a 6, and then replace this one with a 10. And, oh, it's plus 10 though. Is it plus 10 or minus 10? Oh yeah, it is minus 10. Okay. So I got negative 8.2825. The fourth digit is a 5. The number after that's a 1. So the 5 is going to stay down as a 5. So negative 8.2825. Awesome. Anybody get a different answer than me and think I'm wrong? Because I don't have my answer. I don't have an answer key here, so it's possible I was wrong. It's unlikely, but possible. Who should we ask? Probably Andrea. Andrea, did you get the same answer as me? Take that as a yes. All right, let's try out number 4 now. Number 4, a lot like number 2. We're gonna divide that number out front first. So we get 16 to the power of n minus 2. This time though, we can see that those numbers actually do divide. So that's gonna equal 50. So I'll go ahead and just write that as a 50. All right, ready to change it into log form here. So we have log base 16. The base of the exponent becomes the base of the log. The 50 goes inside the log equals n minus 2. So what was in the exponent is now isolated. We'll add the 2 over. right, now type it in the calculator as log of 50 over log of 16 plus 2 equals n. $50, 16, 2. All right, so change that to a 50, change that to a 16, and then it's plus 2, right? Okay. So go plus 2. Okay. So 3.41096. So the fourth digit is a 9. But the number after that is a 6, which means the 9 rounds up to 10, which means the one in front of that's going to turn into a 1. So it's actually going to be 3.4110. All right. Let's move on to number 5 and 6 now. So for number 5, all right, so number 5 is kind of a combination of the two things we've been looking at. So I have to get rid of the 3 out front and then the -5 out in the back. So you always do the adding or subtracting first. So I'm going to add the 5 over first. I'll divide the 3 over. 82 doesn't divide by 3, so I'm just going to leave that as a fraction. All right, now we're ready to switch it into log form. So go log base 9 of 82 over 3 equals 2 minus 10x. All right, I'm going to go ahead and subtract that 2 over. All right, and you know what? I'm gonna go ahead and get ready to type this in the calculator now. I'm gonna get a decimal and then divide the decimal by -10. I think that's gonna be a little easier here. So if I'm gonna type this into the calculator, I'm gonna type it as log of 82 over 3 divided by log 9 minus 2 equals -10x, right? Okay. 82 over 3 over log 9. All right, so I get negative 0.4944 equals -10x. But I'm not quite done yet because now I need to isolate x. So x is being multiplied by -10. So I'm just going to divide this -10 over. And we can see that that just moves the decimal one more to the left. So now I have to 4 decimal places, negative 0.0494. Oh wait, it's positive, sorry, positive. Oh, I didn't put the negative on top and bottom, that's why I got messed up. Obviously a negative divided by a negative is a positive, right? Yes. All right, let's do one more. So number 6, I'll subtract the 2 over to start. Divide by negative 8. $45 does not divide by 8. So I'll just leave it as a fraction. So I'm now ready to switch it into log form. So we'll go log base. The base of the exponent was 14. So now that's the base of the log is 14. Inside the log is negative 45. Sorry, is negative 45 over negative 8. I'm just going to write that as positive 45 over positive 8, since we know a negative divided by negative is positive. If you did write it in there as a negative over a negative, as long as you put the 2 negatives, it would still give you the correct answer on that one. That's going to equal 7n minus 7. Go ahead and add the 7 over. All right, now I'm going to type the left side into a calculator, but I got to type it in using the change of base formula. So that's log of 45 over 8 over log 14 plus 7 equals 7n. All right, so I got 7.654, and then that 4 is going to round up to a 5 because of the 8 after it. So 7.6545. And then we're not quite done yet because now we have to divide by 7. We get 1.0935. Already 4 digits. How convenient. Awesome. All right, that's all we got here. You know what? looks like we're not gonna have enough time today to go over those other quiz questions. So let's do that on Monday. We'll go over those quiz questions. We'll also do a puzzle piece on Monday, so be ready for that. So make sure you have your notes back for Monday. And then for the rest of the class period, I did make an assignment here. I think I did. Let's double check here. I did make an assignment on Schoology. Pretty sure. For the notes. Yep, I did 7.4 notes. So if you just did all the notes, all 6 questions, go ahead and attach that, turn it in. If you missed some, then you can go back and watch the video. Yordi, I'll go ahead and show you number 4 in a minute here. But yeah, that's that. So if you're all done with 7.4 notes, then go ahead and submit that into the assignment here. And I think that's all I got. So if you have time over the weekend and you got some missing assignments, you can use that time to make up the assignments. Other than that, we will see you on Monday for another puzzle piece. All right. All right. And here's number 4 for Yordi. Bye.
Thank you, Mr. Berry.
You're welcome.
Thank you, Mr. Berry.
You're welcome. All right. Ben, you did all your notes today? Or were you working on something else? Ben. All right, I got you. Ricardo, you did your notes, right? All right, gotcha. All right, well, you're gonna have a 0 until you show me.
It's gonna be due when it's gonna get done when I get home.
All right.